Fantastic. For our second award presentation, the Yentsch-Schindler Early Career Award recognizes an early career scientist for significant and balanced contributions to research, education, and society. The 2021 Yentsch-Schindler Early Career Award is presented to Dr. Davi Gasparini Fernandes Cunha for outstanding contributions to research on water quality, nutrient dynamics, and aquatic ecosystem health, with direct translation of results to decisively influence policymakers in South America, an exceptional commitment to mentorship, and the implementation of novel citizen science-based approaches to address water management challenges. Dr. Cunha is currently an associate professor at the São Carlos School of Engineering at the University of São Paulo in Brazil. Dr. Cunha is an accomplished aquatic scientist who works broadly on environmental engineering, water quality, and ecology of freshwater systems, both in Brazil and across the world. He has worked on topics ranging from cyanobacteria blooms to water and sewage treatment and nutrient cycling. A nominator notes that one of Dr. Cunha's most impressive qualities is his ability to see how basic ecological ideas translate to applied concerns. A talented and productive researcher, Davi has a sincere interest in translating our understanding of nutrient transport and transformations in streams to develop strategies for preserving and improving stream ecosystem services. Dr. Cunha easily traverses basic and applied science and shares that perspective with the students, collaborators, and citizen scientists he has fostered. Dr. Cunha's work has greatly supported the management of freshwater resources in both the state of São Paulo and throughout Brazil. Davi has established numerous collaborations, including with 15 universities and research institutes, and many private sector entities and NGOs. Cunha's work is highly cited, and his leadership in environmental science has been recognized with numerous awards and honors. In addition to his scientific achievements, Dr. Cunha has been dedicated to education and outreach throughout his career. He balances his extensive research activities with mentorship of graduate students and postdocs and teaches numerous undergraduate courses. In addition, Cunha integrates citizen science into much of his work. For example, he managed a program in which 300 citizen scientists contributed critical data on stream water quality in 3 cities in Brazil. ASLO President Roxane Moranger notes, the pressures on young researchers today are greater than ever before. And as a young scientist, Davi has successfully navigated those pressures, making impressive contributions to teaching, mentorship, and to society. Please join me in congratulating and welcoming our 2021 Yentsch-Schindler Early Career Awardee, Dr. Davi Gasparini Fernandes Cunha.
Okay, so I hope everyone is looking and seeing my screen. Hello, everyone. Thanks very much for joining this section. I hope everyone is safe and healthy, especially during these very difficult times we've been experiencing. Thanks, Amina, for these very kind words and truly wonderful introduction. It's such a great pleasure to share this room with you, with Dr. Kuhl, and with all these great people. It's such a great honor to me to be the recipient of this award this year, especially because it has the names of 2 outstanding scientists, so Clarice Yentsch and David Schindler. So it's really meaningful to me. Thank you very much. In the next 15 minutes, I'll try to tell you what is it like to be a scientist in Brazil during a pandemic, right? So this is the plan for the next 15 minutes. So first things first, my grateful to the selection committee and especially to the award nominators who took some time of their busy schedules just to nominate me, to write the recommendation letters. Thank you very much. And also my warm thanks to the ASLO officers and all board members. When I was thinking about my today's presentation, I had such a great opportunity to kind of step back and think about key moments and key people helping me throughout my career. So my year zero was in 1986. I was born in 1986, and I'll be 35 years old in December of this year. I have to recognize the importance of these two people here. So in 2004, I started my undergrad studies in environmental engineering, and I met Maria do Carmo Caligiuri, who is still a professor at the same department as mine. So during my first year as an undergrad student, I started working in her lab, and she was the first person who introduced me to the research in limnology, water quality, phytoplankton, and all these interesting issues. And also in 2010, during my PhD, I had the opportunity to meet Walter Dodds at K-State University. I spent 6 months there as a short-term visiting student. So these two people played and still play a pivotal role in my career. So thank you guys, and it's really nice to keep collaborating with you. Of course, I have to mention the support of my family throughout these years. And in 2006, I met this wonderful person here. Her name is Juliana. She became my girlfriend, my fiancée, and finally my wife 4 years ago, about 4 years ago. So, of course, it's numerous people. I don't have enough time to thank all of you, but thanks for all your contributions, and you know who you are, and thanks for being part of my life. In 2014, I got my formal position at the University of São Paulo as an assistant professor, and just got my tenure last year. So since 2014, I was really lucky to meet wonderful and great people. So this is just a quick pause just to honor my students. So here in this slide, you can see either former or current students in my lab. I don't have the time to thank you individually, of course, but you know who you are. I'm really proud of you. Thanks for being part of my life as well. Okay, in the next few slides, I'll show you 3 major lines, research lines in my lab. Just some highlights, of course, to give you a flavor of what we've been doing. For each research line, I'm also showing, as you can see here at the bottom of each slide, I'm also showing key partners. So the first one is on artificial reservoirs. So as you probably know, Brazil has an important share of renewable energy sources. Artificial reservoirs are really common in the country, mainly for hydroelectricity generation, but also for flood control, water supply, irrigation, navigation, and other water uses. So here I'm currently investigating trophic state boundaries and criteria. Most criteria were developed for temperate lakes or temperate reservoirs. So we do need to adapt these boundaries, equations, and criteria for our local tropical and subtropical conditions here. We do have the problem on cyanoblooms. So I'm also interested in understanding the tipping points or the thresholds for microcystin production in our artificial reservoirs, and also some nitrogen studies. So I've been looking at some nitrogen uptake by phytoplankton, and more particularly on biological N2 fixation. Here you can see just some bits of our recent study on N2 fixation in tropical reservoirs. In these pictures here, you see that we've been running those 24-hour incubations with N15, right? Just to estimate the fixation rates. So this is just a table from a paper we have just published. And it looks like temperature, chlorophyll, and phosphorus are the most important predictors of N2 fixation rates in our reservoirs. Interestingly, when we normalize these rates by chlorophyll, we have actually lower rates in comparison to the ones reported for temperate systems. We are also establishing some thresholds at which N2 fixation is triggered or stimulated. And for temperature, our threshold in tropical reservoirs is about 22 Celsius. So we argue that it's really common to have water temperature above 22 Celsius in Brazil. So N fixation can occur throughout the year and not only in specific times of the summer or of the spring, for example. And this has important management implications. Besides N2 fixation, we are also studying direct acquisition of dissolved inorganic nitrogen by phytoplankton as nitrate, ammonium, for example, also through N15 incubations. And the cyanobacteria are strictly correlated to the ammonium uptake. So this has important management implications as well. As you probably know, in Brazil, like in other developing countries, wastewater treatment is still largely absent. So the inputs of reduced N forms, nitrogen forms, are really relevant. So this can, bring opportunity for the cyanobacteria to grow and promote those blooms. The second research line encompasses rivers and streams, so running waters. Again, here at the bottom of the stream, at the bottom of the slide, sorry, at the bottom of the stream, at the bottom of the slide, you have, you can see key people working with me in this research line. So here we are especially interested in nutrient and pesticide retention, aquatic metabolic rates, gas emissions. So here you can see Murilo, one of my PhD students, collecting gas samples from one of our streams. Basically, we've been using whole stream methods. So for example, nutrient additions, either as slugs or plateaus. For the aquatic metabolic rates, we've been using the one station method. And basically, we are keen to understand how land use and multiple stressors have been affecting these key ecosystem processes and these indicators of ecosystem functioning. So again, I'm not going into the nitty-gritty of of our findings, but our streams seem to be especially active regarding nutrient retention. So considering the nutrient spiraling concept, our streams usually have the pristine ones, right? The pristine ones usually have shorter uptake lengths and higher uptake rates or uptake velocities in comparison to the temperate ecosystems. So it's an important ecosystem service there related to nutrient abatement. And also regarding the metabolic rates, it's almost impossible to find an autotrophic stream here in Brazil. So most of them are net and strictly heterotrophic, where ecosystem respiration is much higher than GPP. So we argue that further organic matter inputs can lead to further dissolved oxygen consumption, again with management implications. And we are trying to share these messages with policymakers and decision makers, both in the state, in the country level. And the third and last one is on citizen science. So citizen science is the involvement of non-experts or volunteers in any research. I've been using these as a tool for both outreach and research. More particularly, I've been using community-based monitoring to produce baseline data. As you know, Brazil is huge, so citizen science has been offering us the opportunity to produce very high both spatial and temporal resolution data. And we are also interested in how to keep volunteers' engagement, and more interestingly, how can we assess the impact of these projects on their scientific literacy? So this is the bits on citizen science. So here I highlight the Freshwater Watch. It's a global project established in 2012, coordinated by Earthwatch. I'm the local PI here in Brazil. You can see here their map. So each number here represents a full data set of water quality conditions. So the volunteers have been using consistent methodologies across all these continents and countries to assess the water quality conditions and other key indicators of ecosystem health. So anyone can easily visit this website and download the data. So I encourage you to do that if you are interested. Here in Brazil, we are interested on how data produced by volunteers can contribute to the assessment of nutrient pollution and harmful algae blooms in Brazilian streams, especially in the urban streams. So this is how it works. The volunteers go through a training day where they learn key concepts related to water quality, environmental pollution. At the end of the day, we assign at least one stream to each volunteer, and then the volunteer starts the monitoring activities every month or every 2 months and upload this data into the global data set. Right. Of course, we do not expect the volunteers to have microscope in their houses or spectrophotometers in their houses. So most measurements are really simple measurements. So for the water quality indicators, for example, they use colorimetric kits and charts. They use testing tubes. They use pH or ammonia strips. So really simple methods. And among the key water variables, we have nitrate, phosphate, turbidity, and interesting for phytoplankton, they just collect the samples, they preserve the samples, and they ship the samples to my lab so I can run some phytoplankton counts with the help of my students. And finally, the volunteers also take some notes on environmental indicators. And here, it's really important because it's micro scale, right? So the land use in the surroundings, are there any pollution sources? Is there evidence of aquatic life? What are the general weather conditions? So what are the micro scale conditions in each site? And I'm trying to understand how the data collected by the volunteers can be combined with the traditional monitoring approaches and can be complementary to the traditional monitoring approaches. So here you see on the vertical axis, on the y-axis, the density of cyanobacteria, and here you see the number of pollution sources observed by the volunteers. So if you have more pollution sources, it's more likely to have higher densities of cyanobacteria. So it's an interesting way to couple both both observations, the observations from the volunteers and the traditional lab analysis. Same story here, water turbidity, as reported by the volunteers, is directly related to the riparian land use, as they reported. So if you have trees and shrubs, you're probably having lower turbidity. If you have no vegetation, it's more likely to have high turbidity. So just to give you some ideas of what we've been doing and making our models of water prediction more robust with this microscale information collected by the volunteers. Okay, it's been complicated here in Brazil, as you probably know. We have been struggling with continuous cuts to the budgets for science, for education, for research in general, in all levels, from the local level to the federal level. Also, as you probably know, the COVID-19 has been especially challenging here in Brazil for a number of reasons, but mainly for political issues. Last week, we reached a tragic milestone of 500,000 deaths related to COVID-19. We researchers are trying to be strong and resilient and move forward, and we hope for better days because Brazil has a huge potential and will be better in the future. So just to close my presentation, I present here some final thoughts. Of course, these are not supposed to be advice, just some elements that have been helping me throughout my career and that might be useful for someone, especially for young researchers or early career people. So first one is make your research understandable and more visible. So here I mean talk to different publics, adapt your language when necessary. Use your data sets in a fancy way to publish a paper, but also in a simple and straightforward way for communicating to kids, to local communities, to the media, etc., etc. The second one is look after both your mental and physical health, respect your limits. So the point here is make healthy boundaries, create golden hours to take care of yourself. I keep saying to my students and to my friends, we don't have to be super productive all the time, especially now with all this COVID-19, with all these online meetings, with all these online happy hours, okay? And the final one, build connections and be generous. So I'm showing here some pictures of friends and colleagues. I'll show some more in the next slides. But the point here is that I was lucky to meet generous people throughout my career, and I try to be generous to all the people as well. Especially here in Brazil, with all the challenges we have here, there should be no room for competition among researchers. Collaboration has to be improved instead. And I was lucky to meet these super generous people. And the point here is connections are everything. So I thank you very much for your time. This is my email. If you want to send me a message, I'll be glad to be in touch with you guys. I hope to meet you in future ASLO conferences and meetings. And stay safe, everyone. And thanks again for listening.